Hello, Algebra 2. I want to post another video in case you were feeling kind of a little bit stuck on this Focus and Directrix. So this is just an optional video. You don't have to write down these examples. Actually, I'm pulling all these examples straight from Delta Math. So they should look very similar to your homework that you have assigned that is due next Tuesday, the 9th at midnight. So someone asked me, actually multiple students have asked me, hey, is there like a systematic approach? So like I know how to do this first and this first and this first. There is. I mean, this is just, if you ask for a systematic approach, this is what I would give you. So first, um, with this, okay, cool. So with this here, I always recommend plotting your focus and directrix. Remember, your focus is a point and your directrix is a line. All right. You'll tend to see me and Delta Math plot the directrix as a dotted line. Does it matter? Not really. It's just to help you understand what is happening in your picture. So focus and directrix. Okay. Next step, find a distance in between them. So if they're 8 units apart, make sure you know they're 8 units apart. If they're so many units apart, make sure you know that. Now, if you remember, we have our vertex form, y equals a, x minus h squared plus k. That's our goal. We want to write one of those equations, an equation that has an a value, that has an h and a k value. So I always like starting off with our h and k. If you forgot, h and k is your vertex. So next step here, I recommend find your vertex. And if you're like, oh, how do I find my vertex? The vertex is going to be straight in the middle between the focus and directrix. So we'll see some examples in a second, but your vertex is always in the middle between the focus and directrix. Remember, it's on the same axis of symmetry, so that very like line in the middle of the parabola, it's on the same axis of symmetry as the focus. So that means your vertex and your focus are going to have the same x value. Again, your focus and vertex will have the same x value. So if it tells you you have a focus of -7, +5, your vertex will have an x value of -7. Okay, so vertex is in the middle of the focus and directrix. Find your value of p. Now your p value, again, that is the distance from the vertex to the focus or from the vertex to the directrix. Those are both the same values. It doesn't matter if you count the units from the vertex to the focus or from the vertex to the directrix. It doesn't matter because the vertex is in the middle of those two. Now, if you forgot to find your value a, remember the equation is a equals 1 over 4p. A equals 1 over 4p. A equals 1 over 4p. So that means once you find your value of p, let's say your value of p is 3, plug it into your equation here. So that'll be like 1 over 4 times 3, which is 12. So your a value will be 1 over 12. A lot of these a values will be fractions. I'll just let you know right now, they'll be fractions. And use the formula a equals 1 over 4p. And then finally, plug everything you know into that vertex form up there. Y equals a, x minus h squared plus k. So let's look at some examples. A parabola can be drawn given a focus of 3, -7, and a directrix of y equals -11. Write the equation of the parabola in any form. Now, first step, I said, hey, plot your focus and directrix. And luckily on this assignment, it already gives you a graph. It tells you, hey, there's your vertex, I'm sorry, there's your focus, and there's your directrix. So, boom, part 1 done. 2, find the distance. Let me get a pen. Find a distance from your focus to directrix. What's that total distance there? Luckily here, I mean, you could just count the units, or you can count the number of spaces between -7 and -11. Either way, in this case, we got a total distance of 4. Okay? First step, plot our focus and directrix. Next was to find that total distance. Next step, find your vertex. Remember, the vertex is directly in between the focus and directrix. I know on Delta Math, they use the midpoint formula, which is fine. The midpoint formula works every single time. I do think it's a little bit more work, but you can do that. If you have the graph, or if you just plot it out, just count out what's in between them. So clearly, they're 4 units apart. The focus and directrix are 4 units apart here. So halfway in between 4 would be 2. That means my vertex is 2 away from the focus and 2 away from the directrix. Again, it's 2 away from the focus and 2 away from the directrix. And I said earlier, hey, the x value of your vertex is going to be the same x value of your focus because they lie on the same axis of symmetry. So given just this right here, I know my vertex is at that point 3, comma, -9. Okay, so we plotted our focus and directrix. We found that total distance, and then we found the vertex, so that was nice. Next, let's find our value of P. Remember, the value of P is the distance from your vertex to your focus, or the distance from your vertex to your directrix. Either one, whatever you like best. But here's the thing. I already saw that, didn't I? I already figured that out. That was like, hey, it's 2. My distance of P is 2. Oh, that's not good. Perfect. My distance of P is going to be 2. Now remember, next step is going to find your A value. A equals 1 over 4P. And plug in what you know. We know our value of P would be 2. 1 over 8 is my value of A. And then finally, plug in everything you know into your vertex form. So if I gave you a vertex form of y equals A, x minus h squared plus k, we can plug in an A value of 1 over 8. Remember, the vertex, the x value is opposite h. So x minus 3. Sorry about that little edit. That was weird. I know. PowerPoint was messing up. But yes, here, the k value is just the value of k, which is -9 in this case, which gives me my equation in standard form. Now, we're going to do another example like this. However, we don't have, well, yeah, we're doing another example like this. On the third example, we'll have to do something different at the very end. Now, I'm going to go ahead and graph this, just so you know how it looks like. You don't have to graph it. It doesn't require you to graph it on Delta Math, but it's important to know. The vertex right there is always either your max or your min. How do I know which way it opens up? Your focus is always on the inside of your parabola. I'll say that again. Your focus is always on the inside of your parabola. Since the, let me get my laser pointer out. Since the focus is up here, that must mean it must open up. If my vertex was on the other side of my focus and my director is on the other side, which you'll see in a bit, then that means it would open down. That's important to know because if it opens down, you need to make sure that value of A is negative. Remember Tuesday's class? That reflection over the x-axis? That value of A, it's big. Again, that's the biggest transformation we need to know of if it's a negative, that means it's opening down. If it's a positive, it's opening up. So let's try this next one here. Let me change colors. Parabola can be drawn given a focus of 7, 9 and directrix of y equals 1. Write the equation of the parabola in any form. So here, let me do this. Again, I gave you the graph already. That's nothing too crazy, nothing too bad. So I have a focus of 7, 9 and directrix of y equals 1. First step is done. Boom. Next step, find the distance from my focus to my directrix. Now here we are using the graph to our advantage. If you didn't have a graph or you're too lazy to draw a graph, just count the distance between your y values. In this case, it's just the value of 8. Okay, perfect. So we found a total distance. Well, let's find the vertex. Vertex again. It's going to be directly in between the focus and directrix. And again, the x value of your vertex is the same x value of your focus. So here, since that's a total distance between directrix and focus of 8, there's a total distance of 8. Halfway in between that is 4. So go from your focus and count down 4, or go from your directrix and count up 4. Either way, 1, 2, 3, 4. Either way, wow, that looks bad. That is your vertex. So that is at a value of 7, 5. Again, plotted our focus and directrix first, found the total distance, and then we found the halfway point, and the halfway of 8 was 4. From there, we plotted our vertex, and we saw the vertex was at 7, 5. Next, let's find our value of p. Now again, we already found the value of p, because the value of p is the distance from the vertex to the focus or the vertex to the directrix. Either way, it's the same number. That's not good. Perfect. Okay, vertex found, p-value found. Let's find the value of a. So a equals 1 over 4p. And then here we're like, oh, we know the value of p. It's 4. Which leads us to say, okay, 4 times 4, I mean, that's just 16. I passed 3rd grade. So 1 over 16 is our value of a. So now final step, well, kind of final step. Final step, let's write it in standard form. Oh, sorry, vertex form, not standard form. That would be something completely different, which no, it's not bad, but that's for another class day. A value is 1 over 16. Okay, remember, opposite h, comma k. So opposite h, it's a positive 7. So we're at x minus 7. And then the k value is 5. And then let's think, okay, is this going to open up or is it going to open down? Look at your, let me get a laser pointer. Look at your focus, vertex, and directrix. Remember, the focus is always on the inside of our graph. I'm going to draw the wrong graph right now, okay? Notice it cannot be this graph right here. It can't open down like that. It cannot, because the focus is now on the outside of it. Think back to your patty paper activity you did with Davy. The focus must be on the inside. So that means it opens up. So that's good. We don't need to change anything here. Again, if it opened down, that means, hey, a value needs to be negative. If not, it will count wrong, and that will be sad. We got 2 more. Same thing here. Focus 6, negative 5. Directrix y equals 1. Write our equation. First step, plot them. Boom, done. Cool. Next step, find your total distance. That is y equals 1. That is 6, negative 5. So this distance right here, distance of 6. Okay? Now we need to find our vertex. Remember, the vertex is going to have that same x value as the focus. and it's going to be in the middle from the focus to the directrix. So if that is 6, the middle of that must be 3. That means here with a different color, ooh, purple, we're going to go 3 units up from the focus or 3 units down from the directrix. So here, 1, 2, 3. Again, notice that's 3 right there, and that's also 3 right there. So that gives us a focus. Sorry, that gives us a vertex of 6, comma, negative 2. Okay, found the vertex. Awesome. The value of p. Oh wait, we already found the value of p. Now, just to let you know, the value of p, yes, it is 3. Some teachers will go ahead and say this is negative 3. The reason why some teachers will go ahead and do that is because when you plot this graph, notice where our focus is and where our directrix is and where our vertex is. Vertex is right here and focus is down here. That means this graph actually opens down. And so people tend to forget, they always forget that negative a value. So teachers always emphasize, hey, go ahead and make the value of p negative right now, because when you find your value of a is 1 over 4p, you're forced to go ahead and make sure you have a negative a value. Because if you wait to the very end, you probably will forget by accident, because you're like, oh, I did all this math, I did all this work, and you're like, oh, forgot the a, be negative. In this case, a would be just negative 1 over 12. It's negative again, because your focus is always on the inside of your parabola. And if I graph this parabola, it's going to open down. So given all those words, all those things, we're going to go ahead and write our final equation. Y equals a x minus h squared plus k. Our a value again was just negative 1 over 12. Again, opposite h, since it's a positive 6, we'll say x minus 6 squared, and it's a negative 2. 1 over 12, negative 1 over 12, x minus 6 squared minus 2. One more thing. Again, I'm going to emphasize this again. I already said it 18 times. I'm going to say it again. We're going to go ahead and say our p-value is negative, because when we plug it in here, we need to have a negative a value. Because if we do not have a negative a value, we are saying that the graph must open up. But that's not the case, because if it opens up, that means our focus is on the outside and our directrix is on the inside, and it's all messed up. That's not true. We need to have the focus on the inside and a directrix on the outside. Last one, parabola, focus 8, 3, directrix y equals 7. First step, plot them, perfect. And just looking at our previous trend, you know the vertex is going to be somewhere here, which means it must open down. Okay, so you already have that in the back of your mind. Like, okay, it's going to open down. A value must be negative. So go ahead and make p negative. Okay, cool. So here, again, find that total distance. So here, so from a y value of 3 to a y value of 7, total distance of 4. And now we'll use this color. Find your vertex. Vertex again. Have the same x value as your focus, and it's halfway in between that total distance. So since the total distance is 4, that makes this distance 2 and this one 2. So I count 2 up for my focus or 2 down for my directrix. Either way, I get a vertex of 8, 5. And again, is it going to open up or down? Since this parabola, and I'll graph it in, let's see, black. Since it's going to open down, that means our p-value is going to go ahead and be -2. Why is it 2? Because that's the distance from our vertex to our focus, or vertex to directrix. Why is it negative? Because the parabola is opening down. The focus must be on the inside of our parabola. Okay, so now we have vertex. Now we have the p-value. Let's find the a. Value of a, again, is 1/4p. So 1/4 times -2. 1/8. That's our value of a. Finally, wrap it up in a nice big old bow and write your vertex form, squared plus k. So here we know our value of a is -1/8. Vertex, again, since it's positive. And value of k is 5. And with these examples, notice I didn't really give a vertex of a negative x value. So let's just say something different. This is completely different. I'm making this up on the spot. Okay, making this up on the spot. If I had a vertex of -5, 3, and let's say the same a value, whatever, -1/8, the inside would now be x plus 5 squared plus 3. I just wanted to show you that to make sure you understand it's the opposite h value. Biggest thing here, again, that p-value, it needs to be negative because my parabola is opening down. There needs to be reflection across the x-axis since the focus needs to be on the inside. Now, I forgot how many questions there is on the Focus and Directrix homework, but on Tuesday in class, we'll discuss this more, and we'll discuss a thing called horizontal parabola. Very similar, but also kind of different. If you have any questions, let me know. If not, have a great weekend. Enjoy it. Have any questions, let me know. Peace out.